Elu will talk about, there you go, the history of agent-based models and why to use them. Then I come back to speak about labor shares, then here about superstar firms, and then some questions for Color. The introduction, I mean, I'm gonna go really fast because we rehearsed sooner and we were too long, but it's basically the same that Color just explained. I think it's better to save time for the part we bring new stuff. But the focus is on the hybrid model to try to make agent models more tractable, and how even if it's simpler, it's still able to reproduce the main stylized facts. So.
Oh. Yes. So I'm talking about why agent-based models and what's the history, where did it came from, and where are they going? So ABM is a novel computational methodology for representing the behavior of individuals in order to study social phenomena. So it all began very, very before economics. So ABM is not an economics thing. It's used in other scientific areas. And in the 1970s to 80s, it was mainly used in ecology with modeling bumblebee behavior and how they flew around and what rules there are. And in this area, it's also called individual-based models, so IBM. And then in 1990s, we're starting to see social science models that are closer to what we now know as ABM, and all started with this book, The Growing Artificial Societies, by the same Axel guy as the quote is before, so this guy is really big in this area. And they came up with the sugarscape model. So sugarscape is something that the Vienna people already learned about. I've heard you guys did not learn about it here, but it's really important. It's one of the first large-scale agent-based models. And it's like you can click on a link, because we send you the slides, and you can experiment with it in that logo. It's really fun, and it's also a really important base model for nowadays wealth distribution in economics. And fun fact, what I found hilarious was that back then, when you bought this book, you could not download any ABM models, but you had a CD-ROM where you could download Sugarscape and then use it. So yeah, for you guys maybe not so novel, but sorry. So yeah, new developments now use a lot of large language models, and I found this paper, which is crazy. So they have 25 generative agents, so they're all LLMs talking to each other. They live in this sandbox environment and have like their own houses and cafes and schools and jobs and memories, and they are there to like model human behavior. And they also have like familial relationships. I don't know if they start dating at some point, but they throw birthday parties, and also they have a mayor election, and they're also talking about it. So yeah, that's an interesting paper, crazy stuff they're doing these days. So yeah, but let's go back to ABM and economics. So I found this quote by a paper from Farmer, from a Nobel Prize-winning economist whom I shall not name. So I don't know who he's talking about, and set aside that there's no Nobel Prize in economics. He says that agent-based modeling has been around for a long time, but there's still very little success to show for the effort. And probably he means economics, because in other areas it's really taken off. But yeah, not really, especially in mainstream economics. So as you'll know, our regular models are very simplified, approximate a lot. We have our lines and curves, and they are often imperfect, but still like necessary and used to make progress and make predictions. But ABM is very different in that, because it does not rely on equation. It can, as we have seen, but it doesn't have to. And these assumptions, it doesn't have to make any shortcuts for analytical tractability, and also does not rely on equilibria as an outcome, because they're like more dynamical in total. So I also put you this table from the Axel Farmer paper that kind of shows model features, how neoclassical interpret them, and how there is increased reality and realism than used in ABM. So we have a lot of advantages with ABM models. We have a lot of heterogeneity. We don't have to rely on the statistical moments. We don't have to converge anything to compute. There's a lot of flexibility. There's scale, because our population can be as big as we want it to be, or as big as our computer can handle. And replicability, because there's not just one history. Like, we don't have previous data and then do one prediction, but we have unlimited amounts of histories to run through, and then different scenarios we can have in a sort of Monte Carlo distribution and then see what else could happen. So, yeah, all those advantages can also be disadvantages. As we've also heard previously with the black box, maybe these models are just too big, too flexible, too much, and they're also very tricky to evaluate, because you kind of need to go through each line of code and then still like realize what people actually thought about while doing it. It's hard to test and falsify, and the theory basis is extremely important. So I found this quote, which I will end with. A model of everything is a model of nothing. Once you allow for too much complexity, there's no room for inference, and it's just noise. So if we have all the mechanisms, we cannot tell which mechanism is actually important. It becomes an overfitting problem, and there's no pattern, but just noise.
Thanks, Elu. So now about labor shares. One of the key empirical patterns treated by the paper or reproduced by the paper is a falling in aggregate labor share. In the model, it happens through this process that Collier just explained. So economies of scale that brings about or allows concentration that then causes higher markups, high profit shares, and then, of course, lower labor shares. So it's not here, it's here. So then they point to this. We decided that it would be interesting to do a bit of literature review around the falling of labor shares. In Coller's paper, they point to this other paper that they do a really good literature review around this. So they start by pointing out that economists have always had a big fixation with labor share, even if in the past century it has always been stable. Calder famously picked this as his first stylized fact for economic growth, the stability of labor shares. And this interest has exploded recently because of apparent break with this stability, historical stability. In the past decades, there has been a falling on the aggregate labor share. And since then, the paper point that if you put decline and labor share on Google Scholar, you get 12,000 results in books, articles just in the past, like in the decade before the paper. And they point to many different culprits like technological change, increased globalization, China, the market power, declinization, and many others. But then they also point out that even after all these research projects, we still do not have a firm grip of why the labor share has fallen, and if it's a tendency that will keep going or that will reverse. So this is just to illustrate what we're talking about. For the US, some of the major curves they utilize, the BLS one is the official one, which is compensation for workers and self-employed workers. I'm going to go ahead and skip this part a bit because I spoke too much sooner today. But the main difference is that some people think that it's complicated to use the self-employed people's measures. There's a bunch of discussion around it, so you prefer to use just corporate. And then there's the decision between using net value added or gross value added. Net value added takes into consideration the depreciation of capital. And this, I'll go back to that. And this, another discussion around this is in the choice between using net or gross value added, is that if you use, if you take depreciation into account, this brings about many other debates. For example, there has been recently a raise in investment in intangibles. Intangibles, they tend to depreciate quicker, so this has an impact on the labor share measures. That's just my graph from Variations of Capitalism that I wanted to use again. But it's basically just the raise in investment in intangibles. I'll skip so I don't spoil Steven. So basically, they point out in the end that the lack of consensus reflects this underlying ambiguity in the term labor share. So clearly, if you're measuring this, you have to pick something to be the measure of workers' income and something to be the measure of aggregate income. But what do you pick depends on what you're trying to measure. So if you're trying to measure the relative well-being of workers compared to capitalists, you're choosing one thing. If you're trying to disaggregate GDP, you choose the other thing. And then in the end of the vast literature review that they do, they point out that this vast literature explains the phenomenon, but unfortunately they explain this many times over. And if you were to add the effect of all the mechanisms that this literature brings, you will probably find a decline that is 3 or 4 times bigger than the decline that actually happened. And to end, they offer 2 main reasons for that. The first one being that they bring many approximate causes of this decline, but not a fundamental one. So in the end, they end up talking about different sides of the same coin, or the same dice, because there are many sides. And also publication bias, because if everyone agrees that there was a decline, when you start to do studies around this, you will look for factors that brought this down instead of, and you end up overlooking factors that might have had an upward push. How long we still have, just to see if I have time to... Okay, nice. That's a good sign.
10 minutes.
Okay. So then, just to jump out of this complicated measurement debate, we chose to talk about one of the many factors, culprits that the literature brings, which is the fall in unionization of workers. A main argument around this is people say that workers lost their interest in politics and to be involved, but there's actually data showing the opposite. So here, the dark blue line, the dark blue column is people who are either covered by union or who say they would vote, meaning they would be interested by being represented by unions. And the light blue one is workers who are actually covered. So we see there has been actually a raise in the interest, but a steep decline in the actual representation. The second one is a graph that even looks like fake because of how much it illustrates this point. But it's basically the raise in the income of top 10% and the fall in union membership. And the conclusion of this article is that this was actually a result of an aggressive effort by employers to curb workers' capacity and rights to aggregate and to get together. And he defends that we need a major labor law reform to protect these rights. So yeah, I thought it would be nicer to end on this note instead of the measurement stuff. Now, yeah.
So just to finish, Kohler also mentioned superstar firms, and I kind of find interesting how the article also tried to replicate some style facts. So first of all, what are superstar firms? Superstar firms are exceptionally large and highly productive firms that capture disproportionate market shares and earn high markups. So we could say 3 things. Not simply there are large firms, but they are structurally dominant. Grow faster than others, dominate their industries, and make a lot of profit per worker. Second, there is extreme firm level concentration. So the top 10% capture 80 of the total economic profit, while the top 1 alone capture 36, and the middle earn near 0 profit. And third, superstar firms are generational, not just large. So there is evidence that in US manufacturing, many top firms today comes from an early 20th century cohort formed during a major technological change. So what's the key implication of this is that firm sizes are hardly unequal. And this means that firm sizes are distributed right skewed with heavy tails, meaning that few giant firms coexist with many small ones. So just a broadly picture, this is like a McKinsey Global Institute from 2018, and this pictures the distribution of economic profit and the loss that these firms have, how has changed during the past 20 years. And you could see the top, there is like increasing 1.6, and in the bottom, decreasing 1.5. So definitely this kind of distribution is real and is incrementing during the 20 years. And I think it's, like Kohel mentioned, it's definitely a style fact that keeps improving. So in the article, how you can explain this? You can explain this by Gibrat's law, and this law states that firm growth rates are largely independent of size, and the authors address this law by modeling this relationship. And the highlight is that in this independence still produces concentration. So for this, the key assumption is that while the rate of change of the capital stock is proportional to the size, the rate of growth is independent, and it keeps independent. So yes, to change. This Gibber's law emerges over time in the article, and first of all, early in the simulation, maybe it appears that it's not, because there is clearly a relation between the mean of the size and the mean of the growth, but then this relation disappears, and we could say that it reflects a weak form of Gibber's law. And what does this imply for the aggregate outcomes? And here comes the other idea that I also find interesting, this granular hypothesis that when a small number of firms are very large, shocks to these firms can move the entire economy. So superstar firms actually can drive aggregate volatility. Shocks to these firms do not average out, but propagate to the aggregate economy. So not micro anymore, it's more like macro. And Gabois found that this could also explain 1/3 of US GDP fluctuations. And lastly, idiosyncratic shocks to these large firms can drive aggregate profit dynamics, and this demonstrated granularity applies not only to output and growth, but also to distributional outcomes like profit shares. And also this is demonstrated in the article. You could see that these movements in aggregate profit shares are driven almost entirely by firm-specific shocks that the authors try to replicate with this residual. And you could see in the first columns there is a significantly impact of these residuals, and the bottom residual is not significant. And you could say that the authors demonstrate also this empirical fact of granularity. And some final remarks. The key contribution, in my opinion, for this model is not that it explains concentration, but it shows how superstar firms can actually arise from accumulation dynamics and demand feedback. Also, the concentration emerges endogenously through capital accumulation and market share. This kind of challenges the assumption that dominant firms are inherently more productive, and granularity can translate micro into macro. So idiosyncratic shocks can be systemic, and this breaks these representative agent assumptions and propagate this connection micro-level inequalities to macroeconomics. So I would just finish with the first question is for color, that your model suggests that superstar firms arise from accumulation demand feedbacks, but rather than technological superiority. But how this implies that high concentration reflects institutional policy settings? If so, which policy matters most for limiting this macroeconomic fragility, so to speak?
For my question, and also thanks for the presentation. I forgot to thank you, Color, in the beginning because we were nervous with the technical issues. But the question is that the reason for the building of the HAM was the whole discussion around ABMs being black boxes. But there are some views in methodology works that point that all models, in a certain sense, are also structured stories, and also in mathematically analytical models, we can also hide behind mathematics. So based on this, if you could say if this weakness of the ABM of being black boxes could also be seen in some situations as a virtue, because it pushes the economists to clearly work with narratives, as it's always the case.
Yeah, and I talked about the history of ABM and had a small glimpse into AI future, but how do you think will be the future in ABM and economics, and how would or can or will it even impact policy decision, since it's like all of the advantages but all the disadvantages are also numbered? So yeah, what's your take on that? Thank you.
Yeah, thanks for taking the time to read the paper and prepare this presentation. Before I answer the questions, I wanted to say something about this point that you raised about unionization and potential effects of falling unionization rates on the labor share. So what we do in the paper is we formalize one specific mechanism that may have contributed to the fall in the aggregate labor share. And we're not trying to suggest that this is the only mechanism that drives the actually observed change in the labor share. So I'm actually grateful that you also mentioned some of these other channels, because I personally think that these channels are also important. And I would definitely agree that in our model, the dominant firms, they have very high labor productivity, but at the same time, they pay the same wage as the other firms. So in that sense, you could also ask the question, why is that? You know, if these firms are so productive, shouldn't they pay their workers higher wages? We don't address this issue in the model. But I think this is also one potential manifestation of weak bargaining power of workers, that you know, it's empirically well documented that the big firms, the superstar firms, they have these very high profit shares, and that raises the question: why can they have these high profit shares? I think ultimately it's because they can pay their workers a wage that allows them to have these high profit shares. So you can ask the question: why? You know, why are the profit shares of Amazon, Apple, and so on so high? I think this has to do with the fact that, to some extent, that it's hard for the workers working for these firms to fight for higher wages. So I think that there's a connection there, that in a sense that we don't directly address it in the model, but I think our model is to some extent also consistent with these mechanisms, and a richer model could potentially integrate these mechanisms as well. So at least there's no conflict, I think, between these mechanisms that you highlighted and the mechanism that we have in the model. Okay, so yeah, that was one first thing I wanted to say. And then, okay, coming to your questions about institutional and policy settings. I mean, to some extent, I think goes a little bit beyond what we aim to do in the paper, but there is a very rich literature on this, and to be honest, also in the mainstream. And there's, I think, a lot of work in the mainstream on this. And there's people that tend to be very critical of this the superstar firm phenomenon, because they say that, yeah, these firms are highly productive, but at the same time, they also extract rents. And there are people that think about, you know, competition policies and, you know, how to rein in the power of these companies. And now, I mean, with the tech companies in the US, we also see extreme political influence of these companies. And yeah, I think this is I think relatively widely acknowledged among economists also in the mainstream. And to be honest, I think there's people that are way better qualified than me to discuss what kind of policy options are available, because at the end of the day, I'm not really like a micro competition. You know, I'm more like a macroeconomist. So, but yeah, I think ultimately you need some policies that limit, I think, the market power of these firms, that somehow, I don't know, impose certain limits on mergers and acquisitions, for example, or like other mechanisms whereby firms tend to become really large. I think that's sort of the direction. But yeah, beyond that, I don't feel very qualified to comment on this. About the second question, so for me, no, I think I understand the question. I think where I agree with you, or where I think maybe I understand where you're coming from, is that when I read mainstream mathematical models, I often find it really hard to follow. And this is maybe because my math is not good enough, but I think partly it's also because I think it's often very, very poorly presented and very heavy jargon, very kind of written for the 10 other people on this planet that are kind of working on the same kind of model. And so there I really find that even a model that is mathematical and in a sense has a mathematical solution is still a black box, because it's presented in a way that is sort of not accessible at all. And I think the mainstream modeling literature is full of these kind of models. And then if I compare that to my reading experience of the average macro ABM paper, I would agree that these papers tend to be a lot more accessible because the authors tend to be better at also verbally explaining having a narrative of what's going on. So yes, I think if you make that comparison, I agree that I think even the more complex ABMs can be good at developing a narrative and presenting a theoretical idea in an accessible way. But that said, I still think there is also a weakness in the sense that there is then typically like a verbal representation of the model, and then you get some simulation results in the form of figures, and there's then still a bit of a gap where I don't always understand like how a certain result comes about. And you can then sometimes even see it in the way the authors discuss it, that they basically make a conjecture of what they think is going on in the model. And this I just sometimes find a little bit frustrating. Yeah, I don't know if this sort of addresses it a little bit.
I can give a quick response, but then we can move on because I think we have to leave time. But it's, I meant narrative also more in the terms of like how do you read the models? Because with analytical mathematical models, you can say, no, they are just mathematics. I don't need to choose the way I read them, but you still do. And I've read this other paper that said that for ABMs, they are black boxes only insofar, like the amount that they are black boxes depend on the scientific community around them, on the rules we share about understanding these models and everything. So it's not that like they are complete black boxes and the analytical models are not. It was just like narrative on the sense of being more forcing economists to say, no, it's social science still. So.
On the future of ABMs, again, I'm probably not the most qualified person to answer. This is the first ABM paper that I've written. And a few years ago, Steve and I attended a summer school on agent-based modeling, so it's not even that long ago where I like really tried to get started and had no idea how to do this. And so there's people that are in this field for much longer than me and much more qualified. I mean, in the UK, for example, you cited Doyen Farmer. I think he's someone who is really keen on having kind of more policy impact with his ABMs. But I think they're also trying to build like really, really large scale ABMs. And I'm sure there's benefits to that. And maybe this is also convincing, more convincing for some policymakers than these smaller scale ABMs. So maybe the smaller scale ABM that I presented today is more of an academic thing than a policy thing. But personally, I still think we need these kind of ABMs as well, because I don't know how. I mean, because at the end of the day, with Doyen Farmer and his models, is like, I mean, he's going to go give a presentation, and the only thing that everyone else can do is just believe what he says, because you know how you're going to even check like how sensitive the model is to certain assumptions, and like it's very hard, I think, with these big models to really get control as an outsider over the model and understand what it does. And that's sort of the risk that I see, but at the same time, I presume it's easier to get policy impact that way, because then you have you can speak to all sorts of topics, you can calibrate the model, you can claim that the model represents the data really well, and so on. So yeah, I think this probably is to some extent the future of ABM, the bigger like policy-oriented models. But yeah, personally, I think there should also be a role for like smaller scale models for, yeah, maybe for academia, for us to understand a bit better what we're doing.
Okay, thanks very much. Let's open it up. So just to get an idea, how many people would like to ask a question at some point? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about 10. Why don't we do 3 rounds of 3 or 4? Is that all right? Sure. First round, so this side first, and then over to, so who had your hand up on this side? 1, 2, and then 3. So.
Yeah, hi, my name is Leo from Germany. Thank you so much for the presentation. It was very interesting. I just have like a small interpretation question on the simulations which you showed, which was the, especially the green firm was very interesting to me, which like in the middle of the simulation completely shifted strategy and became kind of a big player and like lowered their prices. And I think like later in the model you see like some other firms also having like sudden big drops in their prices and increases in size. And I was wondering what internal dynamics led to this.
Hello. I had a question about one of your main assumptions in the model, that wages grow with when profit grows. Maybe I would have liked to see some empirical evidence of this happening, and if not, I think with Leo that's policy related. So in a way, you are kind of including policy in your model by that assumption in your model.
Hi, I'm Samuel from Germany, and my question was regarding the earlier discussion about like academic models and more theoretical models vis-a-vis like models for policy making. And I was wondering if having like more simplified and analytically tractable firm sector of the model, for example, isn't also a good thing for translating this into a more empirical model, let's say an empirical SFC model, where you don't then take out basically the firm side and do a like ABM sort of structure, but instead use what you have derived in such a model, for example, and use it to derive your behavioral equations for that model, if that is not also an avenue for further research. Thanks.
Okay, let's start with those 3. That works?
Yes. Yeah, thanks for your questions. So on the the green firm, so in this matching algorithm between the buyers and the firms, there is a stochastic element, because there's always a certain share of the buyers that decide randomly in every period which firm to buy from. And so my understanding of this phenomenon, that like relatively late in the simulation you can have one firm that suddenly kind of has a breakthrough and becomes a dominant firm, is that this firm probably underwent like a lucky sequence of random shocks where it got allocated more customers, despite the fact that it was actually not that price competitive relative to the existing dominant firms at the time, but it still was lucky, had a lucky streak, got like customers randomly allocated to it. And then there was probably like a tipping point where this shock was large enough for that firm to also develop economies of scale that allowed it to lower its price to an extent that this sort of runaway effect could kick off. Yeah, where like you basically have a positive feedback effect where they attract a few more customers in one period. They become more profitable in that moment. They can invest a bit more. They become bigger. They benefit from economies of scale, and then they can lower their prices, and then they become also price competitive. So I think that's what's going on. So that's linked to the fact that we have shocks at the micro level in the ABM. about the justification behind our assumption that wages grow in line with aggregate growth rate. So the idea behind this was to say that if wage bargaining doesn't happen at the firm level, but is sort of driven by other mechanisms, so this could either be if you have some kind of collective bargaining, where maybe the unions, they look at some kind of aggregate productivity growth, then this could benefit individual firms whose growth rate is higher than the aggregate growth rate. So their productivity growth rate is higher than the aggregate productivity growth rate. In that moment, they benefit from the fact that the unions are basically operating based on aggregate data, and the aggregate growth rate happens to be lower than the productivity growth rate of the firm. So this could be the underlying mechanism. If you don't have collective bargaining, it could just be that, however wage setting then takes place in that case, that the workers do not know what the productivity of the firm is that they work for. They just have a general sense of, aggregate productivity statistics or some kind of aggregate data that they use to get a sense of, what is a realistic demand that we can make in this context. And so that would be like, a way to justify our assumption that the wage growth rate is driven by these aggregate productivity growth rather than the firm level, or like kind of limited information about what's going on at the firm level. But yeah, I agree with you that to some extent this could represent limited bargaining power of workers, because if they if they had all this information that the firm that they're working for is highly productive, and they could then also turn that into higher wage demands, then the superstar firms would not be able to raise their profit shares to that extent, because then they would have to share their productivity with their workers. And well, we know from the data that this is not really what's going on. So to some extent, our way of modeling that just reflects the reality that the superstar firms do not share all of their productivity gains with their workers. Otherwise, they wouldn't have these high profit shares. But there's different ways one could model this. So this is just one way of modeling it, and there might be some disadvantages to that. I have to say I'm not entirely sure I understood the question. You're asking about an SFC extension or implications of this approach for SFC models?
I'm basically saying that besides the black box argument, there could be an argument based on the equations basically you derive for explaining the same phenomenon, that they are easier implemented to a full empirical SFC model.
Because of the fact that you have sort of equations.
Aggregate equations instead of having individually simulated behavior.
Okay. Yes. Okay. So if you wanted to make use of flow funds data, for example, to build an aggregate SFC model that also has maybe like an agent-based component, it's useful to also have an aggregate representation of the model in terms of equations. Is that the idea?
Yeah, for example, or if you even if you wanted to replace the whole ABM dynamics, but still basically to account for stagnation tendencies that you would maybe find in empirical data that you would use. So basically, same as you could use a theoretical model that is theoretically structural consistent, you could use a model that relies on a more that maybe has some insights from the first ABM about what dynamics are happening on the macro scale. Then you derive equations that explain this macro behavior, and then use this to potentially build an algorithm that succeeds or to act to an algorithm. Or if basically the argument is more from like this like fully theoretical or pedagogical side of having it tractable and easier to strengthen your theoretical argument.
I think the motivation behind our paper was the latter. Yeah, we just wanted to we wanted to have a model where you can use tools like you know, from standard stability analysis. With the HAM, in the end, we have two different equations, and we can, you know, we get like a dynamic system, and we can work out the steady states and under which condition one of the steady states becomes unstable. So the main objective there was to have a model that has heterogeneity, but at the same time you can use this kind of standard textbook tools for analyzing small-scale dynamic models, you know, in the tradition of, I don't know, the Gandolfo type of textbook, you know, dynamic systems analysis. Yeah, I think that was the main objective in the first instance, yeah. But yeah, I mean, there's probably more one can one can do with this methodology. So yeah, we can talk more later.
Okay, so did I get everybody on this side? So now who else had a question? About 7 others? 1, 2, 3, 4, 5. No, people got shy. Okay, let's go. Hannah, yeah, and then Verity, yeah, and then Florian, and then we'll do the others. Yeah. You had one, Florian? Yes. Okay.
Okay. Yeah, hi, I'm Hannah from Austria as well. And my question, yeah, I always wonder about the animal spirits. I like them a lot. And you said that you use in the models homogeneous animal spirits. And when I thought about superstar firms, especially like Amazon, Uber, I think also, anyways, the other, some AI startups, that I felt often they had, especially in the first years, also negative profits. And when you say how the concentrations or the growth paths often come from efficiency-led strategies, which are due to their profit accumulation standards, but in reality, I thought often it's more due to their financial led, and they have huge. They're investing, or they're fueled by speculative capital investments, and yeah, and so I wondered if this could also be somehow implemented, and also with this in mind, then I felt it could be it would influence the path dependency, or what you also showed, and also it could go to an even faster grade towards the stagnation. Yeah, thank you.
I just had a question more related to your objective of like trying to simplify the ABM, and also like in connection to the questions from Elu and Leo about like black boxes and also like policy decision influence, because like you're sort of saying like ABMs are becoming more and more complex, and they're like this. Yeah, I guess like your work is trying to, in a sense, like also overcome this. Maybe you could talk like a bit more about how researchers like in general are trying to overcome this like black box situation and make these models like more accessible. I guess like the context of this question is like at home there are quite a few like complex models more from like the 2010s about like more microsimulation than ABM, and they've been made for social sector like research and government, but like they're so unwieldy and complex, and like the ministries and government become like dependent on the consultants that then create these models. So like they become like super expensive, but like nobody actually really understands them. So yeah, I'm just like really curious to know like how, like if you've seen cool ways to make these models more accessible, and like what else researchers could do to like help with that.
Hello, I'm Florian from Germany. I have two questions, sorry. Like the first is on markups. You say with higher market shares, firms can also charge higher markups. But doesn't that lead like to higher prices and they face like competitive pressure? And the second question is on the growth regimes. So you said like if you are in a profit-led growth regime, then this also favors like those concentration dynamics. And I was wondering if there is also like a reverse causality, whether like those concentration dynamics actually impact the growth regime. And if you have like those superstar firms that are having a very high market share, that they could also maybe like get market share from other countries and influence their growth regimes. And if you would have like a worldwide convergence to profit-led growth regimes, if you have like those concentration dynamics going on.
Yeah, thanks again also for this round of questions. Excellent questions. About the actual strategies of companies like Amazon to become superstar firms. I think I agree with you that the way we model it with economies of scale being related to the size of the capital stock is extremely simplified. And I think it definitely doesn't do justice to real world strategies like the one you mentioned with like initially basically charging prices that you are almost like making losses, and then you wait until you have captured a certain market share and then you do an IPO or something like that. I think it would be cool to model these kind of real world strategies in a richer way, and we simply currently don't do that. But I think this is an interesting idea for an extension of the model. I mean, we're currently working on a revision of the paper, and one of the points that the referees raised was entry and exit. So we don't have entry and exit, and currently we're adding a very simplified version of entry and exit where firms can exit. They would exit if they have zero profits for a certain period of time. But I think what you were talking about is more like an interesting entry mechanism where like a new firm enters the market and pursues a certain strategy to capture market shares, which may even entail zero profits for some time. And it's something that I need to think more. Maybe there is a way we can actually integrate this into the model without making it too complicated. But
it's more about the heterogeneity in animal spirits. If you can model that, you can model a heterogeneous animal spirits for different firms.
The problem with that is I guess we could, yeah, because the investment function that we use is linear, and this is important for what we do because the aggregation, we can achieve this exact aggregation by using the linear investment function. And I have to think a bit more about it, but I guess in theory you could still have heterogeneous animal spirits because they're just like an intercept term in this investment function, so I don't think this would create like big mathematical problems. So I would have to think a bit more about it, but I think it could be possible. But so you would link this somehow to these sort of strategies of firms. Okay, we talk later about this. I didn't fully understand the link between the animal spirits and then what you said later about the strategies for capturing market shares. But yeah, maybe we talk later. I think it's definitely an interesting idea. On the second question, how to make agent-based models more accessible. Yeah, I mean, the paper was partly born out of this frustration that we did not find it very accessible for, none of us did their PhDs in Pisa or something like that. So, if you're not part of the community, if you don't do your PhD at a university where this is sort of part of the PhD program, I think it can be very hard to get into agent-based modeling. There are some summer schools. There's the Ancona summer school, which I thought was really useful, in particular because they use R. I also heard that I think it's the one in Pisa. They have a platform through which you can run the Schumpeter meets KAINZ model, which I think itself might be like written in. I don't want to say things here on video. I don't know. It might be like C++ or like some programming language, but I think they have an interface, and then you can run the model through that interface, and they offer a summer school where they teach you how to do that. So there are some summer schools out there that I think are useful to get involved. But then there's only so much you can learn within 5 days. And so yeah, I think the short answer is I agree. I think there should be more material. I think once our paper gets accepted, we will definitely make the codes available in R. And I don't know, maybe I'm also going to put up a chapter on our website, or a simplified version of the model for the DIY simulation website, something like that. Yeah, I think we need more of that, and we need more like entry-level agent-based models, toy agent-based models. I think it's good to start with something simple, where you really have control over what you're doing, and then you can expand from there. And I think the problem right now is that we have a number of like pretty high-level macro agent-based models, and it's kind of difficult to get started. So yeah, I think we need more of these small scale ones. Third question about the phenomenon that firms with higher market shares, they charge higher markups, and this should undermine their price competitiveness to some extent. So this is true. This is definitely happening in the model. And there is a parameter in the model that determines the sensitivity of the markup to the market share, tau Q parameter. And I didn't show this in the presentation, but in the paper we showed that yes, if this parameter becomes too large, then concentration may not occur, because then it's kind of self-defeating. So because then once the firms become bigger, they get so greedy in a way that they raise their markup so much that this then undermines their competitiveness, and then they lose the market share again. So this can happen if this parameter becomes too large. Yeah, so the concentration dynamics that I showed, they would only occur for a certain value of this sensitivity of the markup to the market share. And on your second question, whether the causality could also run from concentration to the type of macroeconomic regime you have, I think this is not directly possible, because ultimately the macroeconomic regime is determined by the parameters of the investment function and the consumption function. So the marginal propensity to consume, and then the sensitivity of investment with respect to the profit rate, and sensitivity of investment with respect to the utilization rate. These are the three most important parameters, and they ultimately determine whether you have a wage-led demand regime or wage-led growth regime. And because these are exogenous parameters, they are not themselves determined by concentration. But you can have in theory this is conceivable, but we don't have that in our model, because the parameters in the investment function, they are homogeneous across firms. Once you give up on that assumption, it becomes a lot more complicated, because then you cannot aggregate the investment function that easily anymore, because then you would have like heterogeneous sensitivity of investment to profit rate multiplied with heterogeneous profit rate. So you have a nonlinearity basically, and then you cannot aggregate that nicely anymore. And so that's why we're avoiding that, which doesn't mean that it cannot be done, but we currently don't do it. Yeah.
Okay, so all remaining questions. Final call. 3. Okay, works out nicely.
Hi, I'm Jonas from Switzerland. First of all, like we in our ABM class, we looked at a model from Federico Basi where he models this like entry-exit dynamics. Maybe I don't know. Maybe you're aware of this, but it's quite interesting because like it's then not it's not symmetric. So like firms that enter don't automatically exit again when the profit rate falls because then they've already invested and so on. I don't remember 100% how the dynamic was. Just saying. And I wanted to ask a question on like because as far as I only skimmed the paper, but as far as I can tell, like you showed in the paper like one simulation of it, right? And I was wondering like about the kind of like the sensitivity of the different parameters, like that. I was especially wondering if you, for example, lower the number of firms that you have in your model, if you get like more superstar firms or less? Because I mean, yeah, I would argue, for example, like there's a lot of sectors in reality where you never have 500 firms that are competing with each other, even if you I kind of at the beginning or and in a moment where it's quite competitive, the number is quite lower. And I was wondering if this kind of changes the outcomes of the model, and maybe in general, if you are considering in the future kind of to do more of a meta analysis where you run it maybe with like Monte Carlo simulation or something like that. Yeah.
Hello, I'm also Jonas, but this time from Germany. I also have two small questions on specifically your investment function. First is you use the profit rate in your investment function, and I was wondering why you're doing that, because if you like apply the Weisskopf decomposition to the profit rate and then rearrange the investment function, then your profit rate actually disappears and is just a change to the coefficient of the sensitivity of investment to utilization. And I mean, that's why all the people after Baduri and Marklin came up with including the profit share instead of the profit rate. And I was wondering why you were still doing the profit rate. And second question that is more related to your DIY macro page, which is brilliant and which I used extensively in the previous semester. And I was just wondering how you came up with the calibration of your model there, of your models. Because, for example, like the investment function, you also have parameters there, and I was trying when calibrating my own macro models to find empirical data proving these, for example, animal spirits and the sensitivities of investment to utilization and profit share. But I couldn't find any like empirical observations directly showing how these parameters would look like, and so I was wondering how you came up with them.
I'm Luis. I'm also from Germany. I have two questions. One is like a kind of broad, basic one that I always asked myself, and it came up in your presentation again, and that is how much sense does this consumption rate actually make, like relating consumption to the capital stock as a rate? I mean, for investments on it makes a lot of sense, but for the consumption, I always felt kind of weird to me in the end. And the other question is more to your model, and that's why did you decide for using the economies of scale and not, because you have it in there, relating it the productivity growth to the accumulation rates, for example, in the sense of Kaldor-Verdorn. And if you or maybe tested it even with like more endogenous productivities, because it kind of feels like your outcome that the economies of scale are so important is due to a kind of simple function for like what productivity gains depend on. So if you did test for other like commonly proven indigeneities of productivity.
Yeah, thanks again for the questions. So we do a little bit of sensitivity analysis in the paper, but some of it is reported in the appendix. But yeah, so for some of the parameters we do some kind of parameter sweep exercise where we simulate the model for, you know, a certain range of the parameters, and then we show the different levels of concentration that we reach in the model. So some of that is done, has been done, but I don't think we have done it for the number of firms. So maybe this is one more exercise I can do at some point. So yeah, thanks for the suggestion. I would not think that it would impact the results much, but yeah, it's something that I should probably do as well. Yeah, so thanks for this, and I can talk to you later. I'm interested in this paper that you mentioned, that models entry and exit. On the second question, why the profit rate rather than the profit share in the investment function? So this is because of what I already said earlier, is that the convenient feature of this investment function is that it aggregates very nicely. And once you use the profit share instead of the profit rate, this is no longer the case. And this is because if you use the profit share, all of the variables on the left-hand side and on the right-hand side are divided by k. But if you use the profit share, then you have the left-hand side, the investment rate, being normalized by k. But on the right-hand side, you have a variable that's normalized by output. And this creates problems when you aggregate this investment function. Then you basically get a nonlinearity because of that when you aggregate. And yeah, this was sort of inconvenient for what we wanted to do, and that's why we used the version with the profit rate. Effectively, you can generate the same results with either of those investment functions. You can get the profit-led and wage-led regimes for either of the investment functions. That's why we felt it doesn't really matter that much, and we choose the one that is sort of mathematically more convenient for what we're doing. And about your second question, so on the DIY macro simulation website, I mean, I just picked some parameter values, that gave like results that look okay, Yeah, it's like it's a classroom tool. I mean, you can choose your own parameter values. So I didn't really spend much time thinking about the parameterizations. For this paper, now we're trying to calibrate the model using some microdata from CompuStat. So one way of doing that is with the method of simulated moments. So that's sort of a relatively common way of calibrating these kind of simulation models, where you pick a set of moments from the data. So this could be, the average profit share or the variance of the profit share or something like that from the data. And then you simulate your model and you compute the simulated moments from your model. And then you try to kind of minimize the distance between the empirical moments and the simulated moments. And you try different parameter combinations. Ultimately, you pick the one that minimizes the distance. So there's ways of calibrating these type of models by trying to match empirical moments. Yeah, so that's what we're at the moment working on for the revision of the paper. But yeah, I mean, for the DIY macro simulation website, I didn't do that because it's more like a classroom tool to just kind of get a first feeling for how simulation works. On the third question, why normalize consumption by the capital stock? So, in a way, you can start writing down the model in terms of levels. Total consumption, total investment, and then you just divide everything by k, and you just do that because you want to have stationary. You want to have stationary variables because these are growth models. So total consumption, total output, they will grow exponentially because it's a growth model. But because mathematically you don't want to deal with the fact that, in that sense, the model is unstable in levels. That's not what you're interested in. So you want to make it stationary, and you just achieve that by dividing everything through by k. But so that's to some extent just a mathematical transformation that you do to, that is convenient. But if you would you could start from a consumption function where you're just saying consumption is a function of income, and then you divide through on both sides by k. But this is just a mathematical transformation. It doesn't change the economic meaning of the consumption function. So that's why I never had a problem with it, because I always thought of it as just like a mathematical transformation that doesn't really change the economic interpretation.
For example, like we would look at the accumulation rate, so I over k, but the consumption rate that's like as an empirical value doesn't make any sense to me.
Yeah, that's true. Yeah, the C over k is not really a variable in itself that has like a direct useful interpretation. Yeah, okay, I see what you mean. I think if you look at the empirical research, they then sometimes normalize by, well, either they normalize by output, or they just estimate in levels.
But isn't this like a fundamental flaw that we like use a mathematical operation in an analytical model where we use math to explain logics, and then use a mathematical operation instead of something that explains logics, and if there is no logic behind the consumption rate, this mathematical operation also has no analytical value.
I'm not sure I agree with it, because you could still start from a consumption function that has that economic intuition that just says, total consumption is a function of total income, and then you divide through on both sides by k. But this doesn't change the the economic assumption that you made, that you started from. But yeah, anyway, maybe something for the pub. Okay, but just to address your last question, I think we're out of time. Different ways of specifying these economies of scale.
Alternatives to the economies of scale, like kind of add-on, or did you check for any like other ways of endogenized productivity growth?
I think what we do is not 100% equivalent to the Calder-Verdon law. I mean, but one of the reasons for that is I think this Calder-Verdon relationship is formulated in growth rates, whereas our equation is in levels. And so it's not entirely clear how you go back from the Calder-Verdon to a leveled specification, because sort of by differentiating you lose something and you can't recover it. So that's why for me it wasn't entirely straightforward how to take the Calder-Verdon specification and come up with a leveled specification that would work in our model. And I think what we came up with is an attempt to be close to this Calder-Verdon literature, but it's not fully clear whether it's equivalent or not. But the short answer is I think we played around with different specifications, and it chose the current one partly because of analytical convenience. But yeah, there might be other ways of modeling it. So yeah, there might be room to explore other specifications. Yeah.
Okay, thanks very much to Karsten, and thanks very much to all of you.